Hello, and welcome to Chapter 1 of Mineral Exploration and Mining Essentials on the Industry Overview. So this chapter will consist of a series of videos covering a general overview of the mineral exploration and mining industry. In this specific video, we're going to take a look at the mining life cycle, talk about the different stages of the mining life cycle, and also break down mineral exploration and mining a little bit to get a sense of the different components or stages of those two sort of sides of the industry, mineral exploration and mining. But maybe just to get started, I wanted to take a look at a couple of photos, um, starting with this one here. So this is the Gold Strike mine, which is in northern Nevada. Um, Large mine, as you can see here. It's a huge open pit. And just to give you a little bit of sense of scale, so if we look down here, those are some haul trucks, shovels, as well as drills for blast holes. And haul trucks, they're going to have tires that are like bigger than I am tall. So, those are big vehicles, and you can see that they look pretty small when you get down in the bottom of the pit. Also, a couple other things at the back end of the pit here, they're actually placing some waste rock from other parts of the operation. So that's a part of the mine that is now finished with. They're not working on it anymore, and so they are able to take advantage of the pit and place some waste rock in it rather than having to dispose of that waste rock on the surface. And one other part, it's a little hard to see, but just back up here in the top left corner, there's some buildings. That's actually some of the infrastructure for an underground mine that also exists in this same area. So it's both a surface mine, a large open pit, as well as an underground mine. And we'll look at some more photos of underground mining a little bit later on in the course. Now, the sort of opposite of the big, large mining operation like that is this photo here. This is a photo from an exploration camp in the Yukon. A couple of tents there, nicely lit up with some northern lights. And I often think this is why people go into geology and mineral exploration, to be able to stay in places like this and be able to get great photos like that. And then one more photo here. Here is a gold pour at the Pogo mine in Alaska. So this is the end product of most gold mines. And in fact, so what they're pouring out here will be a what's referred to as a doré bar. So it'll be a bit of a mixture of gold and silver, mostly gold, but a little bit of silver in it. And that is the end product at most gold mines. They can ship gold bars right off the site. Not the case with base metal mines so much, or something like a coal mine or a quarry, where the end product is a rock, in the case of a coal mine, or in many base metal mines, what we actually produce is a concentrate, and the concentrate contains a mineral, and that mineral contains the metal that we want, that we're interested in, like copper, for example. So the end product of the mine is actually the mineral that contains copper, and that concentrate then needs to go to a smelter to ultimately recover the copper out of that mineral. And when we get to processing, of course, we'll talk about that in a fair bit more detail, but good shot here of the pouring of gold bars. Okay, so the mining life sequence. I mean, really, this is a good snapshot of what we're going to go through in the course. So, is each of these different phases of the mining life cycle. So, or mining life sequence, as I've called it here. So let's just step through this and look at some of those components and get a sense of what those different phases. So the first one shown up here is mineral exploration. So mineral exploration really has two parts. It's about making a discovery, finding some rocks in the ground that have a commodity of interest, something like gold or copper. And then once you found it, trying to expand that, trying to define, well, how big is this body of rock that contains the commodity that we're interested in, and what are its characteristics? So it's really finding it and then trying to define that body of rock. And let's say we're lucky and we find a big body, a mineral deposit that has a lot of gold in it, let's say, enough that we think that we can make a go at it as a mine. Then we would end up in the next phase here, which is sort of the transition between exploration and mining. And so I might just start with in this list here of the bottom one, financial analysis. That really is around engineering and economic studies, feasibility studies, to determine whether it is economic to actually put a mine into production. Can you take that deposit, that body of rock that was discovered in exploration, build a mine and operate a mine and make a profit at the end? So that's going to be one of your first stages through a feasibility study or a series of studies culminating in a feasibility study. And if in the end the numbers are positive and it looks like, yes, we can do that, then we would proceed forward with permitting. Permitting in most places has two components to it. The first is environmental assessment, which is a broad-based socioeconomic assessment or socio-environmental assessment, I should say, of the operation and the potential benefits and impacts that that might generate. And then if you're successful through the environmental assessment process and you get a certificate, then you would go to mines permitting and get the various permits that are necessary to put that mine into operation. And then also really importantly, consultations. I mean, that's built into the environmental assessment process, but it's also an important step that companies need to take actually throughout the entire mining life sequence, starting with exploration and working all your way through to closure and post-closure of the mine. And that consultation is going to be, of course, with government and government regulators, but also very importantly with local communities and indigenous communities, if there are indigenous communities around the operation. And those consultations serve to really improve the operation, to hear concerns of local people and then to make some adjustments to the proposed mine so that it is hopefully more acceptable and suitable to the people who live in and around where that mine is going to operate. So if all of that goes well and we're successful with our permitting, then we move through to construction. Depending on the size of the mine, that could be anywhere between about a year and let's say 3 years for a really large mine. And then after construction, of course, we move to mining. And mining is where we actually extract the rock out of the ground. Whether it's an open pit or an underground mine, the mine is really that step of removing the rock with a valuable commodity in it, like copper or gold, and liberating that rock out of the ground. Then the next phase is mineral processing. In most cases, we looked at that pouring of a gold bar as an example. So in most cases, the rock that we mine out of the pit is not actually what we're ultimately interested in. If we're interested in gold, well, gold is contained in the rock that we've mined, but we're not mining the gold directly. So in order to recover that gold, we need to process the rock. For most metal mines, that involves a crushing and grinding phase where you break the rock down to a small sand size, small enough that essentially you're liberating the valuable components of that rock, if it's gold or copper, from all the other components of the rock. And then, once they've been liberated, then you can recover the valuable commodities such as gold. And then and I should mention that both, the mine, obviously, and the process plant are on the mine site itself. Those are the two activities that actually take place on the mine site. Then in some cases, it'll need more smelting and refining. Here's that pouring of a gold, here's the picture of the pouring of a gold bar again. Often when we think of smelting and refining, this is a kind of smelting that occurs also on the mine site to produce the gold bars. But as I mentioned a bit earlier, if you have something like copper and the final product at the mine site is a concentrate of a copper mineral, not the copper itself, then that concentrate goes to a smelter that would be off the mine site. Certainly in North America, in many cases, those smelters are in Asia. So the products are shipped to ports in Asia where there are smelters. And then it's at the smelter that the copper would actually be finally recovered out of the mineral that it's contained in. And then the final phase that we've got here is, of course, reclamation and closure. I guess the first point I would say is that reclamation for sure is something that happens throughout this entire mining life sequence, right from exploration on through. Whenever you have used or impacted some area of land and it's no longer needed, then it needs to be reclaimed. And so in exploration, that's often happening every year after you've maybe drilled some holes. The area where the drill was sitting would be reclaimed. Likewise, during the construction of a mine, there's often more impact on the or there's a greater area that's needed during construction than operation. And so those areas that aren't needed for operation would be reclaimed. And then closure really is, of course, about the final closure of the mine. And again, that is something that also, in a way, starts right at the beginning. It's part of your environmental assessment and permitting processes. You need to have a closure plan before you put the mine into production, which I think is really important because if you think about what the land is going to look like after the mine is closed, it guides you in how you operate that mine. So you can operate the mine much more effectively when you're thinking about closure and you design it with closure in mind so you have the least impact and you can close that mine down and return the land to a natural setting or another productive setting as easily as possible. Now, I didn't put an arrow here from closure and reclamation to expiration, but probably in a way there should be one because it's very common for a mine that is closed that people come back and explore for additional resources around that old mine site. One of the things that we will definitely talk about in the course is one of the aspects of geology and how mineral deposits form is that once there's one, there's usually more. And so, uh, a mine may have operated with a certain technology and under a certain economic conditions for a number of years, and it closed down not because there wasn't any more metal resource there, but just it wasn't economic at that time. And then, new technologies, economics change, people come back, they explore, they discover more resource in and around that area, and they restart the mine again. In many ways, that's one of the best places to explore is in and around known or existing mine sites. Okay, so if we take this sequence now and go a step further and just look at some timelines and costs here for each of those phases. So let's start with exploration. So just under timelines here, I put 3 to 12 years in total to a development decision. But I think what's in brackets is also really important, and that is exploration often occurs in starts and stops over one or more decades. So what I don't want to leave you with the impression is that exploration starts and goes continuously for say 10 years and then we move forward with mine development. For one thing, there's a significant number of exploration projects that really never make it to mine development because they just don't discover a deposit that they might not discover a deposit at all, or one that would be economic to develop. And the other thing is that what you commonly find is that a company will come in, it'll explore for a while, might discover a few things, but not quite enough to make a go at it. Maybe at that point the investment community is not interested in in funding more work on that project, and so the company moves on. But they still found something that was interesting, and so then another company comes in and does a bit more work and maybe does that for a few years and maybe doesn't get far enough along that they could develop anything, and it possibly sits without any activity for a while. Then the process repeats itself. So I know where I'm based in British Columbia, many of the mines that are in operation or have gone into operation recently would have been originally discovered as deposits many decades ago. And it actually took that length of time over many years of exploration and the processes of assessment and permitting to actually put it into operation. So exploration can certainly continue for a very long time. In terms of costs and returns, so I'm saying annually people will spend between say $50,000 and 20 million. I know that's a big range. 50,000 is a pretty small project that probably has maybe only a little bit of drilling, if anything. Whereas a $20 million project would be a large project, probably multiple drills on the site and possibly drilling for the, all year round. Total cost to the start of construction, I'm going to say anywhere between 20 and 150 million plus. In some cases, even higher than that. So, it's a lot of money to explore for these things, and keeping in mind there's no return on that. I mean, there is from a stock market point of view, which we'll talk about in a bit, but there's no revenue coming from that operation because there isn't an operation. You're just exploring for something at that point. Permitting and financial analysis. So that period of time, I'm saying 2 to 7 years, including doing feasibility studies, environmental assessment, and permitting. That's a pretty reasonable range. 2 would be pretty short for that whole step of the feasibility study, assessment, and permitting. 7 years might be a bit long, but it often can take that long. And for a number of reasons, sometimes a company just needs time to be able to do its studies. In other cases, the environmental assessment and permitting processes can be quite lengthy. Certainly more than a year, if not 2 or 3 years to move through that process. And the costs of that are in the 2 to $20 million range. Construction, as I mentioned, about 1 to 4 years. I think I said 1 to 3, but say 1 to 4 years, with total costs of around 100 million to over 3 billion to build that full operation. So 3 billion would be obviously a big mine, and that would be at the upper edge of the timeline. 100 million is a relatively small mine. It would probably take a year to build. Okay, in terms of mine operations, 5 to 100 years. So it's kind of a crazy, time range. 5 is a pretty small length of time, to be honest. Today, the cost and effort of exploration and feasibility studies and permitting, etc. It's not that often that it's worth putting a mine into production for 5 years. I would say, in the shorter end, you see ones that are sort of 7 to 10 years. And usually when a mine is first proposed, the mine life probably wouldn't be longer than about 20 years. But coming back to, this theme of geology, that where there's one deposit, there's often more, or that once, all the geological conditions were together to build something like a copper or gold deposit, the chances are there's quite a lot of mineralization there. And so what we see at mines is that maybe they only planned to operate for 10 years when they started, but they're always doing exploration as they continue to work at the mine to discover more resource. And mostly I would say they're successful. In my experience, I would say that, the average mine probably operates almost twice as long as it was originally planned. And in some cases, these really long life mines could go up to as long as 100 years. And of course, in revenue, we could be talking of, hundreds of millions to billions of dollars. And then closure and reclamation. So I'm really talking about, that closure part that happens at the end of the mine life. I'm going to say 2 to 5 years after mining ends to complete all of that. Monitoring, water monitoring, stability monitoring of a tailings dam, for example, will often continue for quite some time after that. It will depend on the operation, but the bulk of that closure work would be done within, typically I think I'm going to say 2 to 3 years. And then the costs of that activity are often in the sort of $2 to $50 million range and are really considered part of the mining costs. Okay, so there's the whole kind of mining life cycle, but in reality, when we talk about the industry, we really talk about 2 parts of it. There's mineral exploration, and then there's mining. So let's look at what are some of those things that go on in mineral exploration versus mining. So here are the main components, I would say, of mineral exploration. Prospecting, that's really making that discovery. Somewhere along the way, you have to make that initial discovery of some valuable minerals in the ground. And so this is a really key part. You hear numbers like only 1 in 10,000 prospect ever becomes an operating mine. I'm not sure if that number is, totally correct or not, but it certainly takes a lot of prospects to actually find a deposit big enough to put into an operating mine. So this is a really critical phase. And then once you've found something, let's say through your prospecting, then you're going to try to prove it up. How big is it? What kind of grade of mineral do we have in that rock or in that deposit? And this is where we use techniques, geology, mapping, rock sampling, geochemistry, which is things like soil sampling, stream sediment sampling, and of course the rocks that go into a lab for analysis, and geophysics, which are things like magnetic surveys or electromagnetic surveys. And each of these different types of techniques, geology, geochemistry, and geophysics, tell us something a little bit different about the ground. They give us a bit more information. They help us to understand the geology in that deposit. And if all goes well and we think we've got a deposit and we've had some good grades come from our rock samples, then we would go with drilling. Drilling is the most important exploration technique that's out there. So I think it's worth keeping in mind that if we have a mine, where is it? It's the rock beneath the ground. So it's buried beneath the ground. And drilling is the only technique that we have that really where we can get down into the ground through the drill, obtain a sample of drill core, bring that back up to the surface, look and study that sample of drill core to really know what's going on beneath the ground. So this is really the key technique, and I'm going to say somewhere in the order of 80% of exploration budgets, maybe even more, are really dedicated to drilling. So if we drill, and we've drilled a lot of holes, and we have discovered this body of rock with elevated, say, copper in it, then the next phase would be to do a resource estimate. And a resource estimate is doing a grade and tonnage estimate. So how big is the deposit and what is the concentration or grade of the valuable mineral that is in it? And I would say that often drilling and resource estimates, they're sort of a cyclical type thing where you drill, you do a resource estimate. Okay, looks pretty good. Let's go back. Let's drill some more. Let's see if we can expand the deposit, if we can define it better, then do another resource estimate, and so on. And if that resource estimate looks positive, then we would usually proceed to something like a pre-feasibility study, which is now that sort of engineering and economic analysis. We got this body of rock in the ground with a grade and tonnage. Can we design a mine and operate that mine economically? Usually we don't make a mine decision out of a pre-feasibility. It's a preliminary feasibility, that's the name, but it gives us enough information to say whether we should really go forward with a full feasibility study and hopefully towards mine operation. And I would say again, also something that cycles back to drilling. Often we will drill some more, upgrade our resource, redo the feasibility study, and that could happen several times before we might continue moving on or even potentially shelve the project for a few years. I kind of draw pre-feasibility studies at the end of exploration. It's not a sort of a fine line, but I think that's a good point to say if the pre-feasibility study is significant enough that we really think we can move towards mine operation, then we move into mining. And the first one I have here for mining is feasibility studies. So those are much more detailed studies than a preliminary feasibility. And of course, we would go into our permitting and assessments and etc. And then everything else that I've listed here that is kind of part of mining is really the whole rest of that mining life cycle. So exploration just sits at the top of that cycle. It's one activity, but as you can see from the last slide, there's a lot of things that go on within exploration. And then mining is really the rest of it. Mine development. So that's the construction, ore extraction, taking the rock out of the ground, processing it, and smelting and refining it to recover the valuable materials, and then ultimately closing that down and reclaiming the mine site. So there's our overview of the mining life cycle and the components of exploration and mining as a part of our Chapter 1 introduction.